Today we're going to be solving equations. We're going to cover all sorts of equations that you've seen in the past, mostly just to review different types of equations and different strategies to go about solving different types of equations. So let's start with this first example. X cubed minus 5x squared minus x plus 5 equals 0. Here's an example where you can solve this by factoring. And in this particular case, you can factor by grouping. So we can group the first two terms together and factor out an x squared, and then group the last two terms together and factor out a negative 1. Now that leaves us with x squared, x minus 5, minus 1 times x minus 5 equals 0. And you can see here now we can group things together because both of those have a factor of x minus 5. So now we can take out an x minus 5 from both of them, and that leaves us with x squared minus 1 times x minus 5 equals 0. Now, we actually can factor one more time. We have a difference of squares with the x squared minus 1, and so that factors down to x plus 1, x minus 1. And then now that you have everything factored, you can just set each factor equal to 0 and solve. So x plus 1 equals 0, x minus 1 equals 0, and x minus 5 equals 0, and that gives you x equals negative 1, x equals positive 1, and x equals positive 5. All right, let's look at example 2. Here's an example where you're working with fractions, and you're working with the x being in the denominator. So the first thing you want to do in a problem like this is, if you can factor all the denominators, you should. So the x squared plus x minus 6 can be factored to x minus 2 and x plus 3. And now what we're going to do is we are going to rewrite the two fractions that are on the left to have the same denominator as the right-hand side. So since we have x minus 2 and x plus 3, and both of those happen to be the denominators that are on the left-hand side, we can go ahead and multiply each of those fractions by the factor that's not there. So for the first one, multiply by x plus 3, both the numerator and the denominator. And for the second one, multiply both numerator and denominator by x minus 2. Now you'll notice we have the same denominator in the entire problem. And now what you can do is now you can just work with the numerator, because you know if you have the same denominators, you've gotten a common denominator, then in terms of fractions, all you're doing is you're adding the numerators together. So now let's just work with that. So x plus 3 times x minus 2 is equal to 4, and that's a much more manageable problem. All right, so go ahead and distribute and combine like terms. So we have 4x minus 3 equals 4. Move the 3 over to the other side. Divide both sides by 4, so x is equal to 7/4. Now there is one other thing you need to do before you can say that you're completely done, and that's because for the nature of this problem, we have x in the denominator. You want to make sure that whatever you get here at the end is not what we call an extraneous solution, and so you need to go back and make sure that plugging in 7/4 back in is not going to give you a 0 in the denominator. In this case, 7/4 is fine, so that is going to be our answer. However, if you had an answer like at the end that was, let's say, x equals 2, that would be an extraneous answer because plugging 2 back in gives you a denominator of 0 in the first fraction. Example 3, we have an absolute value equation. So with absolute value equations, just a reminder of the strategy to use to go about solving these. Whatever's inside of the absolute value symbols can be either positive or negative. So 2x plus 6 could exactly equal 4x minus 10, or it could equal exactly the opposite of 4x minus 10. And so we're going to write two equations. So the first one is 2x plus 6 equals 4x minus 10. And the second one is 2x plus 6 equals the exact opposite. I'm going to put the right-hand side in parentheses, so negative parentheses 4x minus 10. We're going to solve both of those. All right, so over on the left, we have 16 equals 2x, so x equals 8. Okay, and on the right, we distribute that minus symbol and combine things together. So add 4x, subtract the 6, we get 6x equals 4. So that means x is equal to 2/3. Now with absolute value equations, you absolutely can have extraneous solutions as well. So you need to take the answers that you found and plug them back into the equation and make sure that it actually works. So check your answers. So plugging in 8, for example, 2 times 8 plus 6 is 16 plus 6, which is 22. And then on the right, we have 4 times 8, which is 32 minus 10, which is 22. Then the absolute value of 22 is in fact equal to 22. So this answer checks out. Do the same thing with 2/3. So 2 times 2/3 plus 6, 4 times 2/3 minus 10. Let's see, 2 times 2/3 plus 6, that would be 4/3 plus 18/3, which is 22/3. And on the right, we have 4 times 2, that's 8. So 8/3 minus 10, so 8/3 minus 30 over 3, which is equal to negative 22 over 3. Now in this case, the absolute value of 22 over 3 is not equal to negative 22 over 3, so this is extraneous, which means that this problem only has one solution, and that's x equals 8. Example 4, we have an example of a radical equation, and usually with radical equations, if there's just one radical, it's not too hard. You just square or cube or whatever it is they need to do to both sides in order to get rid of the radical. In this case, we have 2 radicals. So this is going to be a little bit longer process, just because we are going to have to do that squaring process twice. So first things first, you want to get one of those radicals by itself on one side. So I'm going to move that square root of x plus 4 over to the right. Okay, now I can square both sides, and that gets rid of one of the radicals. So squaring both sides leaves me with 2x plus 6 on the left. Now on the right, you can think of this as 1 plus square root of x plus 4 times 1 plus square root of x plus 4, and multiply it out. So 1 times 1 is 1, square root of x plus 4 times 1, plus square root of x plus 4 times 1, so we have 2 of those, and then square root of x plus 4 squared is just x plus 4. Okay, so that right-hand side is the result of multiplying that all out. 1 plus square root of x plus 4 times 1 plus square root of x plus 4. Alright, so we still have one more radical left. So what we're going to do is we're going to try to get that by itself as well. So I'm going to move the 1 over to the other side, move the 4 over to the other side, move the x over to the other side. That leaves me with x plus 1 equals 2 times the square root of x plus 4. Now, you could divide both sides by 2 to completely get the square root by itself, but since it's actually attached by multiplication, we can leave it there if we don't want to deal with the fraction, and we can actually just square it here. So we'll square both sides. You just want to make sure here that you square the 2 as well. So on the left, we have x squared plus 2x plus 1. On the right, we have 4 times x plus 4. All right, multiplying things out, moving things over to one side, we have x squared minus 2x minus 15 equals 0. And now we see we have a quadratic, and we can see if we can factor the quadratic. In this case, we can. It looks like negative 5 and positive 3 will factor this for us. So x minus 5, x plus 3 equals 0. Set each factor equal to 0 and solve. So we have x equals 5 and negative 3. Now, like absolute value equations and like the fractional equations that you worked with, we do have to check our answers and make sure we don't have any extraneous solutions. So that means we take the 5, we plug that back in for x, and see if it works. Do the same thing with negative 3. So we have 2 times 5 plus 6, so that's the square root of 16, minus square root of 5 plus 4, so square root of 9, which is 3. So that would be 4 minus 3, which is equal to 1, and that checks out. So 5 is a good answer. And now let's plug in negative 3. So 2 times negative 3 plus 6, that's negative 6 plus 6, so that's 0. And then we have negative 3 plus 4, that's 1, so square root of 1. So now we have 0 minus 1 equals 1, and that's negative 1 equals 1, which is not true. So this is going to be extraneous. So our only answer in this problem is going to be x equals 5. All right, let's do another problem. X plus 1 to the 2/3 equals 4. All right, with rational exponents, another way to write them is to write them in radical form. In this particular case, we can write this as the cube root of x plus 1 to the 2nd power. Okay, so as a reminder, with rational exponents, the number in the denominator tells you the root. The number in the numerator stays in the exponent. Okay, so now to get rid of the cube root, we would cube both sides. That leaves us with x plus 1 squared equals 4 to the 3rd, which is 64. And now we take the square root of both sides. Taking the square root of both sides, don't forget that anytime you take the square root of both sides, that right-hand side becomes plus or minus. So x plus 1 is equal to plus or minus 8. Now getting x by itself, we have x equals negative 1 plus or minus 8. So now you've got two possibilities, right? Negative 1 plus 8, which is equal to 7, and negative 1 minus 8, which is equal to negative 9. Now you can absolutely plug this back in and make sure that 7 plus 1 squared, you take the cube root, that gives you 4. Negative 9 plus 1 squared, take the cube root of that, also gives you 4. So both answers are good. Okay, example 6. So here's a factoring problem, one where you have to split the middle. So we have 4x squared plus 11x minus 3 equals 0. And just a reminder of how we split the middle. So we write negative 12 up top, and where did that come from? That's the 4 times negative 3, gives you negative 12. And then you need to figure out what adds to 11. So two numbers that multiply to negative 12 that add to positive 11, that would be negative 1 and positive 12. And so you take those two numbers and you split the middle term to be negative 1x plus 12x. All right, so now once you have the middle split, you can factor by grouping. So take the first two terms, factor out an x. Take the last two terms, factor out a 3. So we have x times 4x minus 1 plus 3 times 4x minus 1. And that leaves us with x plus 3 times 4x minus 1 equals 0. And then taking each of those, we have x equals negative 3 and x equals positive 1/4. And those are our two answers here. All right, take a look at number 7. This looks pretty similar to the one that we just did, with the exception of the fact that we have x to the 4th instead of x squared, and we have x squared instead of x. Now what we can do here to help us simplify this problem is we can do what's called U substitution, or just substitution. In calculus, you use the term U substitution a lot. So let's say we let U equal x squared. Now by doing that, that simplifies the problem back down to a quadratic. So this becomes 4u squared plus 11u minus 3 equals 0. And by doing that, well, we've actually already solved this, right? This factors to u plus 3, 4u minus 1, and we have u equals negative 3, u equals 1/4. We just did that factoring in the last example. But you're not solving for u, you're solving for x. So now that you've solved for u, we're going to use that substitution that we had before and substitute the x squared back in for u. So x squared equals negative 3, and x squared equals 1/4. Now solving for x, we're taking the square root of both sides. Don't forget your plus or minus. So we have x is equal to, well, this was the square root of a negative number, so you end up with an imaginary number. So the negative 1 gets taken out from the square root, becomes I. So this is x equals plus or minus I root 3. And in the second one, take the square root of both sides. We have x is equal to plus or minus 1/2. And those are all 4 of our answers in this problem. All right, number 8. 4x plus 11 root x minus 3 equals 0. So again, this looks almost like the last example, but it's slightly different because we have a square root of x in there. Now normally you see a square root, you're thinking it's a radical equation, but the problem is we also have an x that's not inside the square root. What we can do is we can still use a u substitution here, but instead of letting u equal x squared, you look at that middle term. That middle term is the square root of x. So we want that term to be of degree 1. So I'm going to let u equal the square root of x, or x to the 1/2. Alright, so if u is equal to the square root of x, then what is x equal to? Well, x is going to equal u squared. So this, again, simplifies our equation to 4u squared plus 11u minus 3 equals 0. And then we've already done this factoring, right? U plus 3, 4u minus 1, and we solve for u. But now u is equal to x to the 1/2, or square root of x, so I'm going to substitute that back in because we're trying to solve for x, not for u. So square root of x is equal to negative 3, and square root of x is equal to 1/4. Now solve for x. So we would square both sides, and we end up with x equals 9 and x equals 1/16. All right, let's do one more substitution problem. 4x to the 2/3 plus 11x to the 1/3 minus 3 equals 0. The key to figuring out how to do the u substitution, you'll notice that for the last couple of examples where we did the u substitution, that first x was always the second x raised to the second power, right? So x was the square root of x squared, and then x to the 4th was x squared squared. And if you look at this example here, x to the 2/3 is x to the 1/3 squared. So that's kind of an easy way to tell, oh, I can do a u substitution to force this to become a quadratic. So we'll do the same thing here. So we'll let u equal x to the 1/3, and that makes the first one, x to the 2/3, equal u squared. So 4u squared plus 11u minus 3 equals 0. We do the factoring just like we did before. And again, that only gives you u, and we need to solve for x. So replace the u with x to the 1/3, or the cube root of x. And then we can cube both sides, and that gives us x equals negative 27. And then x equals 1/64. Okay, so some additional practice problems we'll go through as well. So this first one here, you see 4 terms in there. It looks promising to be a factor by grouping type of problem. So we can factor out an x squared in the first 2 terms. We can factor out a negative 9 in the last 2 terms. So we're left with x squared times x minus 4 minus 9 times x minus 4 equals 0. That becomes x squared minus 9, x minus 4. And then x squared minus 9 we can factor out even further because it's a difference of squares. So that becomes x plus 3, x minus 3. And then set each of those equal to 0, and we get x equals negative 3, positive 3, and positive 4. All right, this next one, another example of where you can use u substitution. We have x to the fourth and we have an x squared in there. So if we let u equal x squared, then we end up with u squared minus 3u minus 10 equals 0. And that's factorable to be u minus 5 and u plus 2. Set those each equal to 0. We get u equals 5, u equals negative 2. And then we can substitute that x squared back in for u. So x squared equals 5 and x squared equals negative 2. And then solve for x. So x is equal to plus or minus root 5. Over here, x squared is equal to plus or minus the square root of negative 2. We have a negative under the square root, so this becomes an imaginary number. And you pull that I right out, and so you get x equals plus or minus I root 2. All right, another absolute value type of problem here. So remember, with absolute value problems, we are going to write two equations, one where 3x minus 4 is equal to 2x plus 1, and one where 3x minus 4 is equal to the opposite of 2x plus 1. All right, for the first one, we subtract 2x and then add 4 to the other side, and we get x is equal to 5. For the second equation, let's distribute that negative, and then we move the negative 2x over to the left, add the 4 over to the other side, and we have 5x is equal to 3. So x is equal to 3/5. Okay, and then we have to check our answers and make sure that they are actually answers and not extraneous. So we plug 5 in, and we have 3 times 5 minus 4 equals 2 times 5 plus 1. So we have 15 minus 4, which is 11. So the absolute value of 11 is equal to 2 times 5 plus 1, which is 11. So 11 equals 11, so that checks out. Okay, over on the right, we have 3/5. We're going to plug that in, make sure that works. So we have 3 times 3/5 minus 4 in absolute values, and then 2 times 3/5 plus 1. So we have, what is that, 9/5 minus 4. So 9/5 minus 20/5, which is negative 11/5. And then over on the right, we have 2 times 3/5, so that's 6/5 plus 1, so 6/5 plus 5/5 is 11/5. And so on the left, we have 11/5 equals 11/5. So that works as well. So this problem actually does not have any extraneous solution. So you want to make sure that you are checking both answers. It is possible that there are no extraneous solutions. It's also possible that there are no solutions. And so you don't want to just check one and say, oh, I found the one that's not extraneous, because they could both be not extraneous. All right, last problem. 2x plus 1 to the 3/2 is equal to 8. So this is a rational exponent, and we can rewrite this in radical form. So remember, in the fraction, the denominator is going to indicate the root, and the numerator is going to stay in the exponent. So in this case, this is the same as the square root of 2x plus 1 to the 3rd. All right, we can square both sides, and that leaves us with 2x plus 1 to the 3rd equals 64. And now we can take the cube root of both sides, and that gives us 2x plus 1 equals 4. And then we can solve that, so subtract 1, divide by 2, and we get x equals 3/2.